We're going to continue comparing fractions today. So on the video from the other day, we learned that we could use fraction bars to compare fractions. So we've got our one whole, because we always want to make sure when we're comparing fractions that our actual whole object is the same size or is congruent, because otherwise we cannot compare fractions if it's not. So here we're going to compare 3/6. So everyone sees 3/6 to 2/3. Okay. And like we said the other day, you always want to make sure that your bars are lined up to the left, because this would be considered 0. So here we have 3/6 that ends here, and our 2/3 ends here. And the other day we said we know which fraction is greater because it's going to be closer to being one whole, which would be over here. So we can see that 3/6 compared to 2/3. Remember, we read these from left to right, just like a book. So 3/6 would be less than 2/3. So today we're going to take that a step further and look at some fractions on number lines. So just as a quick review, when we have fractions on a number line, we start here at 0. We ask ourselves first, have I passed any whole numbers? Well, we can see here that these are not labeled with whole numbers, so we're going to assume that this is 0 on the left and one whole on the right. We know that our number of jumps to get to our point is our numerator. So that would be 3 jumps out of, and then we count the number of spaces. Remember, we count spaces, not tick marks, because we actually have to move somewhere before we can count. So we have 1, 2, 3, 4, 5 pieces in our whole. So that point, represents 3/5. And I'm labeling this because you know Ms. Atwood is a stickler on making sure we label every single thing we do. All right, on fraction B, start at 0, we have 2 jumps out of 1, 2, 3, 4. So we have 2/4 represented there. So if I wanted to compare 3/5 to 2/4, I can see that 3/5 point is closer to being that one whole than the 2/4 was. It's further to the right, in other words. So again, if I were going to compare these, we have 3/5 and 2/4, and we saw that 3/5 was greater than 2/4. Okay, so let's try another one now. First fraction on A, we have 1 jump out of 1, 2, 3, 4, 5. So we have 1/5. For the purposes of this video, I'm going to write it on my whiteboard because these cards don't want to stay still while I'm doing this. And for fraction bar B, we have 1 jump out of 2. So of course that represents 1/2. We can see it's right in the middle of the whole, so we know that's 1/2. And we can see that 1/2 is closer to being one whole than 1/5. So when we write this, we're going to say 1/5 is less than 1/2. And this is a good example of what we did with the brownies the other day. Our numerators are the same. It's the denominator that's different. So think about those brownies. Would you rather have a pan of brownies that are cut into 5 equal pieces or just 2 equal pieces? The 2 equal pieces are going to be much larger pieces, just like you can see here. This space is much larger than this small space here. Okay, so let's look at one more now. This time we have 1, 2, 3. 3 jumps out of 1, 2, 3, 4, 5, 6. So we have 3/6. On fraction B, we have 1, 2, 3, 4. Out of, where's my marker here? 1, 2, 3, 4, 5, 6, 7, 8. Now parents, I know we're going to get to what this represents later. Bear with me. For right now, we're just calling it 3/6 and 4/8. But we can see that these two fractions, the points on the number line are lined up exactly with each other. So that means they're equal. They represent the exact same point on the number line. So 3/6 is equal to 4/8. Now, in third grade, anytime that you have fractions that you're comparing that both the numerators and the denominators are different, you will have some kind of a picture. Whether that's a number line picture, a fraction bar picture, could be fraction circles. We'll do some things with those later on. But if you have something like this, where your numerators are the same, but your denominator is different, you may not be given a picture, but you're going to be asked to explain why 1/5 is less than 1/2. And if you'll just think brownies and remember watching me cut those brownies, it'll make sense to you every time. The smaller the pieces, the more pieces the whole was cut into. So you want to find the denominator that's the smaller number because it means it was cut into fewer pieces and each piece gets to be bigger.